and welcome to the ZEvRA project, and welcome to us here in Rise and Know Your Bin. In this group, we work with composites. So this goes from composite material testing, characterisation, manufacturing composites, and even testing large composite structures. As Rise, we work together with universities and companies and to build sustainable growth and innovation. My name is Yvonne Aitameki, and I'm Senior Research in Composite Engineering. So what is ZEvRA and what is our role? Well, ZEvRA stands for Zero Emissions Electrical Vehicles, enabled by harmonised circularity. And in this project, what we're aiming to do is to develop methodologies, design and manufacturing of the next generation of electric vehicles by using almost fully recycled materials. And if we can do that, what we do is reduce the amount of raw materials we're using, as well as reduce the CO2 emissions. Rise is a work package leader for the digital tools in ZEvRA. So what we're doing here is supporting 5 different tasks, 3 of which are directly related to the use cases that we have. And so the first one is supporting steel recycling. The next one is supporting recycled aluminium. And the third one is supporting recycled plastics and composites. The fourth tool, that is for how do we support the designer so that they can think about circularity at the design stage. And the fifth tool is for tracing materials. How do we enable the tracing materials within these use cases? And how do we implement digital passports? What we're doing here in this lab is we're actually, as well as the coordinating of the work package, we're actually working on the recycled plastics and composites and the tools for that. To be able to do that, what we need is data. And so we need to have good material characterization. One of the things we're doing here is testing the material at certain temperatures and shear rates, tightly controlled, so that we know exactly how the material behaves at different temperatures and with different shear rates. We can then use this data and put this into more complex models so that we can understand what's happening in a more complex process where we're actually manufacturing components. This way, what we can do is we test it on the virgin material, then we test it, we do tests on the recycled materials, we put them into the models, we see how they behave, and we compare the two. If we can see that, okay, this isn't working quite well, then we need to make adjustments to the recycled materials so that we get what we want from the process. So at the end of the day, what we want to do is to support replacing virgin materials with recycled materials. And we can do this more efficiently by using digital tools, because this allows us to test a number of different options. And then we can say, okay, these are the ones that are proving most promising, and those are the ones we should be focusing. Anyway, so where are we now? Well, we've got the models in place. We've run them with the standard material, but now we need to get some more data for the recycled material so that we can run that and compare the two, and then make the adjustments if we need to. If you'd like to know more about the project, please look at the project webpage or contact us directly to find out a little bit more what we're doing within plastics and composites. Thank you very much.